Okay, so on that pink sheet, you have that's not what I meant to do. Hold on. You have a picture that looks like this. Big old circle with a center called A, I believe. And then what I was going to have you do is draw 2 points and call them B and C and draw an angle and measure it. Okay, and let's just say that I did that and this angle was 80 degrees. So nothing else should be out in front of you guys right now, right? So your full undivided attention would be good and respectful. 295 is where we're at in your journals. Now we learned about, this is called a central angle because the vertex is at the center. We learned about this in section 2. And we learned that central angles are exactly the same degree measure as the arc that they intersect. So if this arc is 80, this angle is 80. Okay? Well, what you're going to learn today is about something called an inscribed angle. So if I add another point here and call it D, and then draw in a new angle, what's the difference between this angle, the black one, and the red angle? What's the difference between the black angle and the red angle? Bryn?
The red angle goes all the way to the other side of the circle.
Right. The vertex is no longer in the center, it's on the circle. And so when you do that and you basically take this angle, they're intersecting the same points, you take this angle and kind of like pull it back and stretch it, you are making that angle measure smaller. And so what you would have discovered is that this angle would have been 40, and then what's the relationship between 40 and 80? 40 is half of 80. And so that was our big exploration, and then you all would have had different angles, but unfortunately we're going to skip that just for the sake of you guys getting some work time. So that would have led us into our first theorem here. Okay, an inscribed angle, first of all, vocabulary-wise, is an angle whose vertex is on the circle. So it's no longer in the center. It is on the circle. And then it says whose sides are chords of the circle. And then you're going to hear me say intercepted arc, most likely. So the intercepted arc, you can write that one, or let's maybe, well, no, you should probably write that down because it's on your test. But I'm going to add in something here. It's the arc that the angle intersects. So basically, your intercepted arc is the piece of the circle that the angle is cutting off. And so then what I just showed you and what you would have seen in that exploration is this theorem right here. So I'm going to add your big theorem of the day right here. The inscribed angle measure is 1/2 of the measure of its intercepted arc. Or in other words, the arc is double. The arc's always bigger, so you can think about it either way. The angle is half the arc, or you can think about it as the arc is double the angle. We're going to have to work both ways anyway. But your inscribed angle is no longer exactly equal to the arc like the central angles were. It's half. And again, if you think about it as like you're taking your central angle and pulling the vertex back, you've now like stretched it and made it smaller. If you would like kind of loosen up the angle and give it some slack, then it would probably get bigger. So our first problem here, first one says find measure angle T, and they should have used 3 letters. So we're looking at RTS. The angle is half the degree measure of the arc that it intersects. So since it intersects this arc right here, it's going to be half of that measure. So how big would angle T be? If the arc that, Jace? 24, because half of 48 is 24 degrees. The angle is half the arc that it intersects when it's on the circle like that, when it's inscribed. Okay, then it says find measure arc QR, which is this arc right here. Now, we don't have an angle directly, we're going to have to do a little bit of extra work here because we don't have an angle directly cutting off that piece of the arc. If we had an angle that was intersecting that arc, we would be able to just take that measure and double it, but we don't. However, we know this is 48, and actually this is a diameter because it goes through the center. So what's half of a circle? 180. So all of this is 180 right there. This angle is cutting off arc Q to T. So Q to T has to be double that angle. What's double 50? 100. So now we should be able to find QR because all of this is 180. This is 100. So how would I find the rest of that? Jace? So how much is it? Okay. So again, and I could have thought about it as just half the circle here too. So half the circle is 180. This is 100. So then the rest of that would be 80 degrees. In my head, for some reason, I was thinking the 360 route. I could have added 180 to 100 and then subtracted from 360. Okay. Questions? This second theorem it's called the inscribed angles of a circle theorem. This basically says if you have two different angles that are intersecting the same arc. So there's angle C, and it's intersecting arc AB. And here's angle D. Well, D is also intersecting arc AB. If arc AB was 40 degrees, okay, then angle C would be half of that, because it's always half the arc that it's intersecting. So what's half of 40? 20. So angle C would be 20 degrees. Angle D would also be half of 40, which is 20, because angle D is also intersecting that arc. So this theorem says if you have two angles that are intersecting the same arc, then they have to be congruent to each other, which should make sense, because they would both be half of whatever that measure is. So if you have two different angles that are intersecting the exact same arc, they have to be congruent to each other. So like this problem here, angle E is 75 degrees, and they ask us to find angle F. Well, E and F intersect the exact same piece of the circle, the exact same arc. And so since they intersect the exact same arc, they have to be the same angle measure. So E is congruent to F, and therefore how big is angle F? 75 degrees, exactly equal to angle E. Question so far? Okay, you don't have this next slide on your notes, so just eyes up here and let's follow along, and I'll ask for some volunteers. First one says find the measure of the red angle. So we're going to find this angle here. The angle is half of the arc that it intersects. The arc is always the bigger part, so the angle is always smaller. So who can raise their hand and tell me how big that red angle would be? Jake? 45, half of 90. It intersects a 90-degree arc. Half of 90 is 45. Very good. Number 2, we're being asked to find this arc. So if this angle intersects it, who can raise their hand and tell me how big arc TV would be? Arc TV. Luke? What'd you say? The arc is the bigger one. So he cut 38 in half, but we don't want to cut it in half. We want to reverse that process and double it. So what's double the 38? Besides Jace. I've heard a lot from Jace today, although I appreciate it. I've heard from Jake too. What's double 38? Andrew? 76. 76. Very good. Yeah, the arc is always the bigger part. Always. I just think an angle gets like bigger the further out it goes. And then the last one, we're looking for angle X. Well, angle X and angle Y intersect the exact same arc, and two angles that intersect the same arc have to be congruent to each other. So who can raise their hand and tell me how big angle X would be besides Chase? Two angles that intersect the same arc are congruent. Seth? Thank you. Okay, so I know that wasn't on your sheet, but there's a little overview for you. All right, that's the basics of today, the inscribed angle stuff. Angle is half the arc. Arc is double the angle. Questions? Okay, last couple of vocab terms here. We're not going to write down a term for sub 10, so don't worry about that. But last couple here. An inscribed angle is an angle whose vertex is on the circle. So an inscribed polygon is a polygon, so 3 or more sides, whose vertices are all on the circle. Last couple vocab terms. So again, an inscribed angle is an angle whose one vertex is on the circle. So an inscribed polygon is just a polygon who all of the vertices are on the circle. And to remember what polygon just means it has 3 or more sides with no curves and no gaps. And we'll get into that actually more next chapter. And then that circumscribed circle is just the circle that goes around an inscribed polygon. That's probably not too terribly important of a vocab term to know. But you should know inscribed polygon. And that prefix circum means around. So like circumference, circumscribed. And then inscribed means inside. So we're going to go over 2 theorems here, one involving a triangle and one involving a quadrilateral. So what makes something a triangle? 3 sides. What makes something a quadrilateral? 4 sides. All right, our first theorem here with the triangle. Let's think about this. If we have a triangle, here's a diameter. Diameters cut circles in half, yeah? So this angle right here, angle B, if it's intersecting a diameter and it's intersecting this arc AC, it has to be half of that arc AC. If this is a diameter, how big would arc AC be? 180, half the circle. And then what's half of 180? 90. So anytime you have an angle that intersects like a diameter or a semicircle, it has to be 90 degrees. And that should make sense because half of 180 is 90. So that's that first one. It says if a right triangle is inscribed in a circle, the hypotenuse has to be the diameter and vice versa. If you see a diameter, the angle across from it has to be your right angle. The second theorem with the quadrilateral, let's look at this one real quick. And this one took me some time to figure out where their formula was coming from. Let's look at 2 opposite angles here. So I'm going to look at angle D first. Okay, angle D is intersecting all of this arc, E through F through G. What angle is opposite of angle D, across from angle D? Corinne? Angle F. Angle F is intersecting all of this arc from E through D through G. Well, if you look at the red arc and the green arc put together, that's the entire circle, right? How many degrees is an entire circle? 360. And what's half of 360? Right, and so since these are inscribed angles, they're half the arc, and so it should make sense if their arcs make up an entire circle, then their angles would make up half of that, which is 180. So this theorem says anytime you have a quadrilateral, anytime, then the opposite angles are always supplementary. So write that down if you need to. So if you ever have a quadrilateral inside of a circle, the opposite angles would always be supplementary, which makes sense because their arcs make up an entire circle together. Opposite angles are supplementary. Okay, what does supplementary mean? Add up to 180. Great. So this first problem, you have that triangle. Here's your diameter. Which angle is across from the diameter, A, B, or C? Which one's opposite, or which one is intersecting the diameter, A, B, or C? Okay, C. Here's angle C, intersecting the diameter, half the circle. Half the circle is 90, or sorry, half the circle is 180. Half of 180 is 90, so 2x has to equal 90 degrees. And then they just want us to solve for x, so what would x equal? 45. We're also getting confused on when to put degree signs and not. I've noticed that on people's homework. You put degree signs anytime you're dealing with an angle measure or an arc measure. So it would be appropriate here to put a degree symbol. Would not be appropriate to put it on like a chord or a radius. That would make sense. And then theorem 2, opposite angles in a quadrilateral are going to be supplementary. So who can raise their hand and give me a pair of opposite angles up here? Actually, I'm just going to call people now. Trey, give me one pair of opposite angles in that picture. What? E and G. Okay, so E and G have to add up to 180. And then the other pair would be D and F. So D and F also have to add up to 180. And then you would solve for both variables. And that's a quick one step. So DJ, what would Y be? 60, because you just minus the 120 over. And then same Hayden, what would Z be? 100, because you just minus the 80. The opposite angles are supplementary because that's what makes up the entire circle. They're arcs. Okay. So real quick, back to that first theorem. Here's your diameter. Who can raise their hand and tell me which angle in that triangle would be 90 degrees? L, K, or M? Which angle in that triangle would be 90 degrees based on where that diameter's at? L, K, or M? Besides Jace, although I'm super appreciative of it. Tanner. L. So our X would be 90 degrees. And then how could I find Y? Who would like to walk me through finding Y? Jake? Add the 90 and 40 and subtract from 180. Why would we do that? Very good, because this is triangle, and triangles always add up to 180. Very nice. So we get 50. Okay, those last two opposite angles are supplementary. So on number 5, or letter B, or however I named it on yours, Zach, can you point out one pair of opposite angles for me?
On number 5?
Yes.
B and D.
B and D. So X and 82 have to add up to 180. And then the other pair, A and C, also have to add up to 180. So this shouldn't take you very long. Delaney, what would X be? 98. I'm gonna go ahead and have you give me y as well. Very good. Okay, and then the last one real quick just involves a tiny bit more algebra. Tyler, on that last one, can you point out one pair of opposite angles for me? B and T. So 8x and 10x have to add up and equal 180. 8x plus 10x is 18x. So it just involved one extra little step here of adding like terms. Divide by 18. You don't need a calculator for that. What's x going to be? 10? We shouldn't need a calculator for that. And then the second pair would be S and U. So the C and then the 2C minus 6. Let's just be careful on our algebra here. C plus 2C minus 6. The 6 still stays a minus. Even though I know you're adding the angles, you still got to keep the minus 6 the way it is. We can't change it to plus 6 all of a sudden. So 2C plus C is 3C. Add 6 over. We get 3C equals 186. Divide by 3. We can do this one in our heads as well. How many times does 3 go into 18? 6 times. And then how many times does 3 go into 6?
2.
That should have been, that was a 186, not a 180. I know I said 60 because I messed up. Okay, but now your worksheet is not, directly like this. You're gonna have to do a little bit of extra thinking and a little bit of extra work. So I'm gonna let you guys try. I think you'll be okay on the back part of it. I think you'll be, those are the notes. I'm gonna let you guys try it before you ask me any questions, okay? You're in here until 12:10. Oh yeah, I gave you a lot more work time than first hour. First hour got nothing. So go ahead, I don't want you to move. Go ahead and sit where you're at. And then if you need some help, you can come talk to me or talk to the people around you. Or if you wanna just quickly get up and ask someone, like a friend, and then go back to your seat, you can do that. But I want us working and focused. I was asked for more work time, so I'm giving it to you. We have to use it wisely.